Hello students, in the previous classes we have learned about different types of fibers that made the fabrics that are available in the market today, and you learned the properties and also the consumer preferences. Now today let us see how to identify these fibers when they are there in the fabrics, so that we can take care of the fabrics and also we know how to actually utilize these fabrics for various end uses. A large variety of consumer goods are available in the market today, and textiles is one of them, and the labels are present on all textiles generally, but sometimes the labels may not be there, and also the information on the fiber which is used in this particular fabric may not be present. In that case, when a consumer goes and buys the material because he likes it, since the information is not there, he does not have the capacity to analyze that particular fabric for the particular end use for which he has bought that material, and also how to maintain this particular fabric. So, he will be at loss because he bought the fabric, but he could not get anything he has invested on the particular material. Generally, fabrics are labeled as per the legal requirement. The manufacturer provides the information of the fiber content. When the fabrics are made into products such as apparel or home furnishing, and the label may be present or it may not provide information on the fiber content. If the fabric fails to perform as per the end use requirement, the consumer loses his investment on the product. Therefore, consumers should have knowledge about the properties of the fiber in the fabric, so that he can compare its performance against the price range of fabric and also its intended end use. Now today the market is flooded with many counterfeit textiles that resemble the genuine fabrics, but give very poor performance. The consumer will be confused to take care of these fabrics during laundering, and so to address these problems, it is advised that the consumers should build themselves with the knowledge of the fibers, properties of fibers and their processing. This helps to the consumer to easily identify the fiber content in the fabrics, and also can take an intelligent decision about purchase of the fabric or its product. The knowledge of the fiber identification is also required for the wholesaler and also the retailer, as they have to deal with customers and they are answerable for all the sale transactions. This knowledge may also be much useful to forensic scientists to deal with some criminal cases where the clothing of the victim will be a prime evidence. The Textile Fiber Product Identification Act of 1960s, brought in by the federal government of USA, has provided the classification and generic names to different fibers and instructed the manufacturers to provide information of the fiber content on label. As per the law, it is mandatory also. The Act also clarifies many issues related to the fiber products and their identification. Now, let us see what are the types of tests that are present to identify the fibers. So, the consumer will be at a greatest disadvantage when the composition of the fiber content in a fabric is not known or it is not given in the label. He cannot go for laboratory analysis, but he can rely on certain non-technical tests to arrive at the fiber groups at least. Non-technical tests, in the absence of special equipment and facilities for identification of the fiber content in a fabric, one can rely on non-technical tests such as appearance, feeling test and burning tests. These tests have limitations of their own, but helpful to identify the fiber group and also sometimes the fibers. The first test is the physical appearance test. In this, the physical appearance of a fabric sometimes indicates the probable fiber content. Generally, natural fibers can be identified tentatively. The yarns are drawn from the fabric separately, warp-wise and also weft-wise. The parameters checked are the fiber length, the luster, the fabric surface and the fabric weight. The fibers are either staple or filamentous. Generally, all natural fibers are staple except silk. However, spun yarns are made even from filament fibers by cutting and spinning on the cotton system, and so you will not know whether it is of a natural one or also the man-made one. The luster of the fabric can be an indication of the fiber content such as silk, rayon, polyester or any other synthetic fiber. Cotton is dull, but mercerized cotton is little bright. Silk has luster that is different from other fibers. Rayon has maximum luster. Banana, linen and jute type of natural fibers also have little luster as compared to cotton. Fabric surface may be smooth, soft or hard, and in this case wool is soft to touch, bast fibers are hard to touch, all synthetic fibers are very smooth to touch. The fabric heaviness can be tentatively checked in hand. If it is light in weight but looks voluminous, it may be wool. All natural and man-made cellulosic fabrics are heavy. Linen fabrics are made little heavier than the other cellulosic fabrics. All synthetics are generally light in weight. Then coming to the feeling test, it is purely perception of the feeling of a fabric when it is handled. One acquires this expertise after handling many fabrics. To understand this skilled perception, run your fingers over the fabric. When the fingers become warm, it may be a wool fabric, or if the fingers become cool by losing heat, it may be one of the cellulosic fabrics such as cotton, linen, jute or even rayon, which is a man-made cellulose, as these fabrics are very good conductors of heat. One more examples of this skilled perception is silk crepes and chiffons versus rayon or polyester crepes and chiffons. Silk is smooth to touch while others are hard to touch, but this test has a limitation of identifying the exact fiber content. Then we have another important test that is called burning test. Among the non-technical tests, burning test may be reliable as it gives scope to identify the fiber groups used in daily use textiles. The fibers vary in their burning properties, and that makes sense to utilize the test for identifying the fibers. The yarns in a fabric should be separated from the warp side and the weft side, and they should be tested separately, because we may have one fiber in the warp and another fiber in the weft in case of union fabrics, and so it is always better to take the burning characteristics of both the warp and weft yarns. And when you take the yarn near the flame, we have to do some observations. So, what happens when you take the fiber near the flame, in the flame and after removing from the flame, and how is the rate of burning, and what is the odor that you are getting, and also what type of residue that you are getting. So, these are the observations one have to make. When you take cotton fiber, cotton fiber is a cellulosic fiber and it is taken from the plants, and so you find that when it is taken near the flame, it ignites readily and also sometimes it scorches, and when you put it in the flame, it takes up the flame readily, and then it also continues to burn after removing from the flame, and it gives a afterglow, and then once the fire is put off, and you find that the smell of a burning paper you will get, and also the residue is going to be feathery light grey ash, and it may be light to grey in color, and sometimes if it gives you black color ash, then it may be a mercerized fiber. If you take a linen fiber and it does not shrink, but it ignites upon contact and it burns with a yellow flame, and it continues to burn even after removing from flame, and the rate of burning is quick, but it definitely slower than cotton, and it gives a paper burnt smell again, and it gives feathery grey ash. Coming to the rayon, which is also a cellulosic fiber, and but it is a man-made fiber. It also does not shrink, but it ignites upon contact. In flame it burns readily, it continues to burn even after removing from flame, and the rate of burning is going to be very fast. It also gives paper burnt smell, it gives around light grey feathery ash. Then coming to the protein fibers like silk. Silk curls away from flame when you take it near the flame, and it burns with difficulty within the flame, and once you remove from the flame, it is self extinguishing, and the rate of burning is slow, and it gives a burnt hair smell, and also it leaves crushable black brittle bead. When you crush it, it will be crushed into ash. And another protein fiber is the wool. This wool also it curls away from flame, and when you put it in the flame, it burns with difficulty and sometimes sputters, and when you remove from the flame, it is self extinguishing, and the rate of burning is very slow, and you get a strong burnt hair smell, and it leaves a crushable black brittle bead, and this also will be crushable, and so when you crush it, it becomes a black ash. Coming to these synthetic fibers, polyester, it fuses, melts and shrinks away from the flame when you put it near the flame. In the flame, it takes up fire readily, but it continues to burn even after removing from the flame, and the rate of burning is faster, but it is little slower when compared to the cellulosic fibers, and it gives aromatic smell, and the most important thing here is the residue. This is, it gives uncrushable bead. And taking the nylon fiber, when approaching flame, it also melts away from flame, it shrinks and sometimes fuses, and within the flame it takes up fire readily, and once it is removed from the flame, it is self extinguishing just like the protein fibers. The rate of burning is going to be fast, and it gives aromatic smell, and again the bead is uncrushable one. So, this uncrushable bead is an indication that these are all synthetic fibers. And the other synthetic fiber is the acrylic, which looks like wool. While approaching the flame, it melts and fuses away from flame, and it takes up the fire readily in flame, and it continues to burn, dropping the molten polymer off once you remove the fiber from the flame, and the rate of burning is going to be fast and gives around acrid smell, and it gives irregular hard black uncrushable bead. And we have lycra, which is also used today in most of the fabrics, stretchable fabrics. When it approaches the flame, it fuses and it does not shrink away from flame, and in flame it burns with melting, and after removing from flame it continues to burn with melting, and it gives a chemical smell, and the rate of burning is going to be moderate, and it leaves a soft, sticky and gummy residue because it is a very soft material. Apparently, the burning properties of many fibers show similar characteristics which may confuse the consumer, but it provides preliminary examination and scope to eliminate some of the fiber groups. It gives a broad conclusion about the fiber groups present in the given fabric. So, now we will see what are the technical tests. So, when laboratory facilities are available, it is better to use them to confirm the fiber content. These techniques are much more reliable for the fiber identification than the non-technical tests. However, it requires knowledge and skill in handling analytical equipment and chemicals. So, we have the first is microscopic test. When the microscope is available in the laboratory, we can utilize this, and this is conducted to help to identify fibers with distinct features such as wool. Longitudinal view of the fibers show the surface characteristics of the fiber. The fiber is cut perpendicularly to get a thin cross section, and when viewed under the microscope, it reveals the contour or shape of the fiber with its internal structure. Generally, an optical microscope with 100x magnification is used to have clear picture of the fiber's longitudinal as well as cross sectional view. A projection microscope can be preferred as the magnification is higher and the bigger screen facilitates tracing of the fiber shape. A polarizing microscope with a fiber lens provides good contrast and can be used for most specific observations such as extension bands in cotton fiber. To make a sample, few fibers are withdrawn from the yarn and placed on a slide in parallel fashion. To make a thin cross section, microtome is being used. The longitudinal view of the fiber and the cross sectional shape can certainly provide some useful information for identification of the fibers. The table portrayed here gives the microscopic view of the textile fibers. In case of cotton, when cotton is viewed longitudinally and it is flat twisted ribbon like with convolutions, and these are all tapered to one end of the fiber, and the cross section is kidney shaped or bean shaped. In case of linen, when viewed longitudinally, it looks like bamboo cylindrical structure with defined cross marks, and the cross section is polygonal shape, and it consists of ultimate cells. That means that around 10 to 40 cells make an ultimate cell, and it is going to be polygonal in shape. And silk fiber, when viewed longitudinally, it is cylindrical with uneven diameter throughout its length and show lumps, folds and cracks on the surface. And the cross sectional view of this show a wedge or triangular fiber and with rounded corners. Coming to the wool, when you see the longitudinally, you find that it is cylindrical in shape, but with the overlapping rough cells called scales. These are all directed towards the tip of the fiber. In cross section, you find oval or elliptical cross shape, and the fine fibers show a central hollow canal called medulla, but it may not be seen in all the fibers. In case of rayon, it is cylindrical with distinct longitudinal striations or the parallel lines, but the cross section is going to be serrated in shape. You take the acrylic fiber, it is rod like shape and having uniform diameter and some irregularly spaced striations or parallel lines are seen in this, and it is nearly round or bean shaped. In case of nylon, it has a rod like cylindrical structure with smooth surface, but delustered fiber may show a spitted appearance along the length of the fiber. And in case of the cross section, we find it is round in shape, and sometimes it may have even the spitted appearance if it is a delustered one. And polyester, it looks similar to nylon. It is rod like cylindrical structure with smooth surface. Delustered fiber again show a spitted or a peppery effect inside the fiber, and the cross section is going to be round with again with a spitted appearance. And actually some of the functional textiles, you may find the round shape of the fiber may be changed into a square, or it may dumbbell, or it may be triangular, or it may be a different shape depending upon the function it is supposed to perform for the in the particular textile. And the spandex or the lycra fiber, it is broad and often indistinct lengthwise striations are present, and there are no cross markings on this particular fiber. And the cross section may be dog bone type or it may be a square. Coming to the chemical tests, which are going to be very important tests for confirmation of these textiles. So, use of chemicals for identification or confirmation of the fiber content in fabrics is the ultimate technique without the use of much advanced techniques. In this we have a solubility test. The fibers are soluble in some of the acids or alkalis or organic solvents. By taking results of the burning test, microscopic tests, chemical tests can certainly provide useful information of the fiber. So, if we take cotton, cotton dissolves in cupra ammonium hydroxide and cuprethylene diamine, and linen fiber, it dissolves in 75% sulfuric acid. But cotton is also dissolves in 75% sulfuric acid, but by other tests we can confirm the linen. If we take silk, silk dissolves in concentrated hydrochloric acid and also it dissolves in 10% of sodium hydroxide solution. But wool, if you take, it dissolves in only 10% sodium hydroxide solution, but it does not dissolve in hydrochloric acid. But when you dip a paper in lead acid solution and expose it to dry wool fumes, then you find that the white lead acid turns brown. This is another confirmation test to wool. And rayon becomes slimy in fillings A and B, and also it dissolves in most of these, even in 69% of sulfuric acid. And the acrylic fiber, it dissolves in N-dimethyl formamide solution. And nylon dissolves in phenol, whereas polyester dissolves in metacresol. And the spandex lycra fiber, it dissolves in dimethyl estamide or dimethyl formamide solutions. Then the density of the fiber is also an indicator of the fiber identification if a density gradient column is available with the consumer. Density is the mass per unit volume of a substance measured in grams per cubic centimeters. When you take these natural fibers and man-made fibers, generally natural fibers such as cellulosics are more having more weight when compared to other fibers. And when you take these synthetic fibers are lighter in weight. Cotton fiber is a heavy fiber and consisting of density 1.54 to 1.56. Linen has a density of 1.50 and silk has a density of 1.25 to 1.34 and wool has a density of 1.30 to 1.32 and rayon has a density of 1.50 to 1.53, and whereas acrylic has 1.16 to 1.18 and nylon has a density of 1.14. This is the lightest of all the fibers that we use, and polyester has a density of 1.23 to 1.38 and spandex or lycra fiber has a density of 1.20 to 1.25. So far we have taken an overview of the technical and non-technical tests for identification of the fibers. These methods can throw light if the fabric is made of 100% of one fiber. In case of blends where the yarn in a fabric is made out of 2 or more than 2 fibers, it is difficult to identify all fibers present in the fabric. Other advanced techniques used especially for detection of the fiber content in blends are optical and electron microscopy, infrared spectroscopy, UV visible spectroscopy, nuclear magnetic resonance spectroscopy, X-ray diffraction, thermal analysis. The quantitative analysis of the fiber blends depends mainly on eliminating one of the fibers by dissolving in a suitable solvent and finally estimate the content of the fiber left out. In case of tertiary blends, that is having 3 fibers, 2 fibers need to be eliminated by following the procedure twice. So, students, today we have learned about the different techniques of identification of fibers in the fabrics. This information is very much required to assess the end use performance of the fabrics and also their proper maintenance in use.